Okay. All right, so here's a sheet. We are not going to do this whole thing, but what I will do is, I will do the whole thing, and you're free to do whatever we don't do on your own, and then come in and check your answers. Okay, did everybody get one? All right, so notice that there's, so notice that there are two sides to it. And that's just because I had two sides. So it was easy enough to do. So let's start, and I have different shapes on each side. So let's do two on the front side. So I'll let you pick the two that we do together. That's the side that has the curve. Let's see. That looks like this. Okay. So this is our function f. So on that front side, there's 5 options there. What do you want to do? The one right next to it. So that would be 2f of x plus 1. Now, before we start, let's just make a quick note of what we're going to change in words. What's happening here in words? What am I going to do to my picture? What's it doing? Left 1. And so it's twice as tall. And you can use your own vocabulary, you don't have to say that, but it's 2 times as tall. The height is times 2. So if I move everything to the left 1, then I'm going to do that first. I'm going to take everything, and you're on graph paper there, so it's easy for you to do. Just take each point and move it 1 over to the left. All right, so that point now is going to be over here. That point is going to be up here, and that one's going to be there. Okay, so there's my triangle. Now, this is getting the same thing. 1, 2, 3, 4. So there is my picture. Move 1 unit to the left. Is that okay with everybody? Now I'm going to make it twice as tall. Now, don't pick it up. It is glued. All you're going to do is take its peaks and valleys and stretch them. So how tall is that original triangle? 2. So now he's going to be stretched and he's going to be 4. These points aren't moving. They're glued on there and you're just stretching him. How deep is this triangle? So he's going all the way down to 8. So the blue one is the answer. Feel free to use a colored pencil. Or if you want to erase like I do, that's fine too, whatever. Everybody okay with that? All right. One more from the front side. We'll do one more from the front side. What do you want to do? The one underneath the original one. stretched me. Would my feet move? No, I'm gonna stay standing on the ground. You're sweating. Wish that were possible. I love these all over. I said I'm shrinking. All right, so what's happening in this? I heard somebody say flip. Now, that's really not enough. How does it flip? This is an up and down. This is an upside down flip. Where does the negative go if I want to go sideways? Right there, right. It's there, I'm sideways. It's not, it's upside down. All right, what's this doing? Shortening it, it's making it half as, no, that's a height. It's making it half as tall. This number multiplies the height. Whatever that number is, it multiplies the height. So since it's a half, it's going to multiply the height by a half. What does this do? Up 1. My brain does not, I can't process a ton of things. So I'm going to start by doing this. I'm going to flip it upside down and make it half as tall. So back to the original. See that triangle right there? Instead of going up 2, it's now going to go down 1. It's half as tall and upside down. This guy went down 4, so he's going to go up 2. So I have flipped it upside down and made it negative. And made it half as tall. Flipped it upside down and made it half as tall. Now I have to move every point up 1. So it's easy on graph paper. Just take each of your points and move it up 1. 1 block. Connect the dots, and there we go. Nyla?
What do you do if the number is inside the parentheses, like, the one on the bottom right?
Well, somebody tell her. What happens when the number's inside the parentheses? What does it do? It's the width, but what does it do to the width? Divides the width. Yep. All right, flip it over. Flip it over. Now I got a different shape, and we'll do a couple from this side. So before I erase these, we have reviewed several concepts here. A number out in front multiplies the height. Adding or subtracting in the parentheses moves you left and right. +1 went left, -1 would go right. A negative out in front flips you upside down. And a 1 or some number tacked on the end physically moves you up and down. Plus is up, minus is down. Okay? So let's see if we can review some other concepts on the back. So now we have a different picture. What do we need to review back here? Okay, so here's my shape I'm starting with. What do we need to do? Lauren?
Y equals 2f times 2f.
So the last one. Oh, that should be a G. Oh, I used F for all of them. All right, let me just call this F of X. All right. So let's talk about what these things are doing before we actually try to do it. We've actually already talked about them. What does this one do? Multiplies the height. So this original triangle was 2, that was 2, well now it's gonna be 4. What does this do? Divides the width. So the original triangle was 4 wide, so now it's only gonna be 2 wide. Now, is anything moving? No, nothing's moving. All we're doing is stretching, shrinking, or whatever, right? So, if you can handle both changes at once, that's okay. If we need to do it in 2, we can do it in 2. I'm gonna go ahead and do it in 2. I'm gonna make everything half as big as it was, this one. I'm dividing the width by 2. Dividing the width by 2. So that triangle now is only going to be 2 across. So there's my triangle. My trapezoid, 1, 2, 3, 4, was 6. So now it's only going to be 3 across. Now I have not changed the height. So my triangle was still 2, this was 2, and this trapezoid is 3, original. I haven't changed that. Now I'm going to change that. I'm going to double it. So I'm going to take my triangle, put it down to here. So instead of going down 2, now it's going down 4. And my trapezoid, instead of going up 3, it's now going to go up 6. So there's my figure, twice as tall and half as wide. Okay? What else do we need to review? What other concept on the back side here do we need to review? We haven't done any absolute value. Let's do the one right next to this one. You gotta pay attention to where the absolute value is, right? So this one is just around the X. Who remembers how that transformation works? If it's just around the X, what does that mean, Meg?
It like you flip it onto the x-axis. Is that right? Is that
I'm not sure. I'm not understanding what you mean.
sideways?
So I don't flip the entire picture. That would be if there were a negative on the X. Then I would flip the entire picture. I do flip part of it. This is the one where I draw the right side. So whatever's on the right side of the picture, which in this case is this trapezoid, whatever is over here, I draw it. And then, Meg, I draw exactly the same thing on the other side. So this is a picture of this. When you take the absolute value of just X, you draw whatever's on the right, and then you reproduce it on the left. So take it and fold it over on the left. Now, there's another step to this problem though. What does that tell me to do? Flip it how? Upside down. So now I have to take my trapezoids and flip them upside down. answer would be that. Okay? Now, I think we covered everything except we didn't do the big absolute value, absolute value of the whole problem. So let's do the one that says absolute value of the whole problem plus one. Now, we know what this does, right? What does this do? This plus one on the end, up one. Physically, pick it up, put it up here. But how do we do the absolute value of the whole problem? The whole thing, bottoms up. So, in other words, if it's up there, like my trapezoid is, it stays there. But if it's below, if it's on the bottom of the picture, I have to bring it up. So I would have that. That's what happens when you do this right here. The absolute value of the whole thing is bottom part comes up. Now, then, we simply pick each point up, one thing. And the blue would be the final answer to the problem. Okay? I'll do the rest of those at lunch. And, look at it. Alrighty, so tomorrow we're gonna have a little quiz. We won't have nearly that many problems on it, but just to make sure you are keeping up with your rules. Alright, now let's get our notes back out. Take about 10 minutes worth of notes, and then we can go to lunch, and then we'll come back and take more notes. Alright, so remember what we started yesterday? What did we start yesterday? It was so fun. What did we do? We made a box. And what was the purpose of making the box? To maximize the volume. That's right, we wanted to get as many M&Ms in our box as we could. Guess what? We're going to do another one right now. This is a guaranteed test question. It's a guaranteed exam question. You need to know how to do the box. What are you doing, Peter? Put that in your bag. Actually, no. Give it to me. You pick it up from student services at the end of the day. Alright, here we go. You have picked a piece of paper. Same exact scenario as yesterday. It's 21 by 16 this time, so it's a different size paper. We're going to cut out the corners. And we're going to find the volume. So domain, maximum volume, and the size of the corners. So 3 questions to answer. Who remembers the setup for this? I need an equation. Who remembers? Katie?
Minus 2x times 16 times 2x times x.
Yep. Kids, isn't our equation always going to be one dimension minus 2x times the other dimension minus 2x times x? That is never going to change. That's going to be the setup every time. Okay, you don't need to multiply that out because our calculator is going to do the work. You do have to tell me the domain though. because when I plug this into my calculator, I have to know an X-min and an X-max. Otherwise, I might look at the wrong part of the graph. So, what are my minimum and maximum X values? You like?
0 to 8.
0 to 8, he says. What do the rest of you think? He's right. Always 0 because X can't be negative, can it? Okay, so 0 is the bottom. And then where did the 8 come from? Half of 16? Taking a chunk off both sides? Okay, so when I go to my window on my calculator, 0 to 8. Now, I need to do Y's also. Remember, Y is the volume. So isn't your minimum Y gonna be 0 too, also? And then max is a guess. So mine's still set at 200 from yesterday, so I'm just gonna leave it there and see what happens. Type in your new equation. Make sure you type in your new equation. Did this happen? What does that mean?
The window isn't checked.
The window isn't high enough. So what am I gonna adjust? What item in my window needs adjusting? Y max. So maybe I'll go to 400. Ooh, that's still not big enough, is it? So maybe I'll go to 600. Oh, that's good. Now, can somebody use a number other than 600? Yeah, what's the point? You have to be able to see the top of the hill because you're looking for the maximum, right? All right, let's find it. I see it now. I've got the top of my hill. So I'm going to second calc maximum. And I got a point. Oh gosh, is it 3,450? That doesn't happen very often. Did you get that? Usually it's some decimal weird thing, but this one came out pretty even. All right, so let's answer the questions. What is the maximum volume of the box? 450 cubic inches. 3 inches, yep. And how big are the corners that I should be cutting out? 3 inches. 3 by 3. Let's say 3 by 3. 3 by 3. Okay, everybody all right with that? Because we gotta go on to some different kinds of problems now. Are you good with that? Box problem? All right, number 3. A jumper that normally costs $11.50 is on sale for 30% off. And sales tax is 7%. So this is exactly what happens to you when you go to the store and you're gonna buy, you know, your favorite teacher a new jumper, and hopefully it's on sale or you got a coupon or something, and you're gonna have to pay sales tax. We can do this problem in multiple steps. I don't wanna do it in multiple steps. We can do it in one step. If it's on sale for 30% off, I do not want to multiply by 0.3 because multiplying by 0.3 tells me how much I'm not paying. And I'm really not interested in that. I want to know how much I am paying. So if I don't have to pay 30%, how much do I have to pay? 70%. So I'm going to multiply it by 0.70. 70% of the original cost. That's what I'm paying. If you multiply it by 30, you're gonna have to subtract. If I multiply it by 70, I'm done. Now, this 70, by the way, is 100% minus 30%. That's how we got that 70. Now, don't multiply by 0.07, because all 0.07 is gonna do is tell you how much tax is, and then you're gonna have to turn around and add it. So instead of multiplying by 0.07, what if I multiplied by 1.07? Because don't I have to pay the 100% of the cost and then an additional 7%? So what I am multiplying by, kids, I'm not gonna do any addition and subtraction. I am multiplying by 100 minus 30 and 100 plus 7. When I'm discounting, it's 100 minus, and when I'm adding on like a tax or a tip, it's 100 plus. I just type that in and I have my answer in one quick step, which by the way is exactly what the cash register does. Are you paying $8.61 for this jumper? What you got? All right, one more and we're going to lunch. Repeat number 3 for a $16.95 shirt on sale for 18% off. So if it's being discounted 18%, then what am I gonna multiply it by? 0.82, 0.82, 100 minus 18. If the tax is 5.5%, then what am I gonna multiply by? 1.055? And that will tell you how much you are gonna pay for the shirt. I got $14.66, did you? Perfect. All right, that's it for now, and I will see you back in your seats at 49. Take care of all your business. Come back, I will see you then.
Oh, Mrs. Ford?
Yeah.
I'm leaving for an appointment midway through lunch.
I need to eat your lunch.
So should I just